All right, so in chapter 2, basically we're going to be solving systems of equations. And so you may remember back to algebra 2, or I don't know, algebra 1, whatever. And so in 2 dimensions, of course, in 2 dimensions, you know, you could have x plus y. Well, you can do it a couple different ways. Let's do y equals first. You know, y equals x plus 2, y equals 3x plus 1 or something, minus whatever I said. And then, of course, this one, because they're both equal to y, they're both equal to one another. We just call this substitution, of course. 2x equals 3. X is 3 halves. 3 halves plus 2 is 1 half plus 2 is 3 and a half, I guess. 3 and a half would be like 7 halves. And that would be your point. And remember, that is where those two lines cross one another. 3 halves, 7 halves. And that's all fine and dandy. Okay, piece of cake. Now, of course, could have done that differently. Could have done something like this. Oftentimes, you'll get one of these guys. Whatever. Hey, look, if I subtract, what do I get? I'll get 1x. Y minus y is 0, of course. And, of course, 7 minus 4 is 3. We call that elimination. Okay, we're going to get more into that today, but in a different fashion. Hey, if x is 3, then that's 9 minus 2, so y would be negative 2. And that's great. And with two dimensions, it's pretty easy to do. I don't really care how you go about it, whether it's this way or with graphing or any number of ways to do it. It's a pretty neat way to do it. Once you get into systems of equations with 3, you know, it gets pretty bad. It gets pretty ugly. I'll still never forget my first year teaching. I had to assign all these nasty equations to my algebra 2 kids. And the good kids, of course, would do them. And when it was all said and done, I would spend hours grading the stupid things. And I would be like, yeah, well, look here on page 2 of your solution, you dropped a negative sign somewhere and whatever. And then the kids would be like, oh, no, and then be all mad at themselves. And that's how life goes. So, I gotta think what I'm doing here. Trying to make this come out correct in my head. I think that's right. Now, in this case, you've got 3 equations with 3 unknowns, yes? Because you have 3 equations with 3 unknowns, we say this thing has full rank. Okay, that is, you have to have the same number of equations as you have unknowns. Now, it's full rank as long as there's a full solution here. Okay, now be careful with that, because it's quite possible, although it's not in this case, it's possible that say this equation and this equation are the same equation if you like they were multiples of one another. Okay. So one has to be careful of that. It could also be a situation where you could take a linear combination of this one and end up with the middle one, for instance. And so that can't happen. So we're going to talk more about rank later on. It comes up quite often. The idea of you need 3 equations with 3 unknowns. If you had 2 equations with 3 unknowns, you can't solve that equation. You don't have enough information. If you had 4 unknowns and 2 equations, yeah, you can't solve that either, right? They have to be the same. Okay, so, you know, back in the day, you may have solved this a number of ways. What we are going to do is create ourselves a matrix and there's a couple ways to solve this, but we are going to use what is referred to as an augmented matrices, or an augmented matrix, where these are the coefficients, 3, 1, 1, 1, negative 1, 2, and 2, 2, 1. And then over on the other side are our answers. What we're going to do is we're going to play elimination. This is what actually referred to as Gaussian elimination. The game we're looking for is this. When we're all done, where I'll have 1x equals A, 1y equals B, and 1z equals C. That's what we're looking for when we're finished. We're looking for the identity matrix on this side. Now, how do we do that? Well, here's what you can do. You can multiply any row, multiply or divide any row by a constant. You can add rows or subtract rows. In order to, and you can combine those. You can multiply one row by 2, let's say, one row by 5, add them together, boom, there you go. Again, the idea being is that you want to end up with, when you're finished, something that looks like this. Okay? Now, to play that game, let's see what happens. Well, first and foremost, I think I would like to get a 0 here. What would I do to get a 0 there? Well, I could times this row by 3. And then I could subtract it from the top row, or I could times by -3 and add it to the top row. So that's what I'm going to do. So the top row I am not changing. I'm going to times -3 times 1 is -3. -3 plus 3 is 0. -3 times -1 is +3. Plus 1 is 4. -3 times 2 is -6 plus 1 is -5. -3 times 4 is -12 plus 11 is -1. And so we've got a 0 there. Yay! Now I would also like to get a 0 here. Now how am I going to do that? Well, I need to multiply the top by something and the bottom by something. Now I could times the top by -2/3, for instance. Are you with me? I could do that. That's just weird though. Don't do that. So if it were me, I would times the top by 2, let's say, and times the bottom by -3, let's say, and then add them together. So if that were true, I'd get 2 times 3 is 6. This is -6. When I add them, I get 0. 2 times 1 is 2. This is -6. 2 minus 6 is -4. 2 times 1 is 2. 2 times -3 times 1 is -1. 2 minus... All right, try it again, Jay. 2 times 1 is 2. -3 times 1 is -3. 2 minus 3 is -1. That's what I meant to say. And then you're going to get 22 minus 27 is -5. So these are taken care of. Now, if you're asking me what I do next, my next step is usually, well, my next step will be these guys here. In no particular order. Well, if you're asking me right now, I'm just going to add row 2 and row 3. Are you with me? So if I add row 2 and row 3, and let's just go ahead and write number row 1 by itself, because I'm not going to fool with him right now. So I'm going to do that. So 0 plus 0 is 0. 4 plus -4 is 0. That's handy. -5 plus a -1 is a -6. And then, of course, -1 minus 5 is -6. Oh, that is hot. Nice. Now, it's at this juncture, what I frequently do is go, oh, now wait just a minute. If I were to do this right now, okay, I kind of want a 1 right here, don't I? So I could divide both sides of this guy by -6. And so, I'm just going to keep going down the page. Yay! So that's cool. I need to get this to be a 0 now, yes? So I'm going to times the top row. And times the top row by -4, I guess. No, I'm going to times the top row. Yeah, I guess. And then I'm going to add them together. So what I'm going to get is, now remember the bottom row is not changing. I'm not changing the middle row this time. I'm going to multiply the top row by -4 and then add it to the second row. So if you will, -4 times R1 plus R2 is what I'm going to have. So that's -12 plus 0, -12. -4 plus 4 is 0. -4 plus -5 is -9. -44 minus 1 and -45. Well, that's nice. Okay? That's pretty handy, right? Well, what we need now is we need this guy here to be a 0, and we need this guy here to be a 0. Well, the only way you're going to get that is to take and add R3 to these guys. Seems pretty easy to me. So I'm going to take R2 plus 5 times R3 this time and see what happens. So I'm not fooling with the top one. Middle one is going to become, let's see, 4 plus 0 is still 4. And then it's going to be negative 5 plus 5 is 0. That was the whole point of that. And then it's going to be negative 1 plus 5 is negative 4. Well, that's nice. Is it? I guess it's nice. In my head, I had a different answer, but that's cool, I guess. Is that right? Guess we'll find out in a minute, kids, huh? Oh, boy. Now I need a 0 here. So if it's me, I'm going to take and I'm going to multiply. I'm going to take R1 plus 9 R3s. And that will give me negative 12 plus 0 is obviously negative 12. 0 and 0 is 0. That's cool. So you get negative 9 plus 9 is 0. And you're going to get negative 45 plus 9 is negative 36. I didn't change the middle one at all. And lo and behold, I'm to here. That's nice. Now, I would like this to be a 1. So I'm going to divide by negative 12. I'm going to divide by 4. And I'm going to end up with 1, 0, 0, 3, 0, 1, 0, 1, negative 1, 0, 0, 1, 1. And so, my answer is 3, negative 1, 1. This is where those 3 planes would cross one another. Okay. Now let's see if that actually satisfies my original equation. 3 times 3 is 9. Uh-oh. Somewhere I dropped a negative sign. That's no bueno. Es no bueno, señor. No bueno. Just a minute. Oh, it's right there. So R2 plus 5 times R3. So that'd be negative 1 plus 5 is positive 4. Which is what it was supposed to be all along. It was freaking me out. Anyway, you'll know you're right or wrong or not because 3 times 3 is 9, plus 1 is 11. 3 minus 1 is 2, plus 2 is 4. 6 plus 2 is 8, plus 1 is 9. Check. We've solved the system of equations. Now, what this is, this method right here where you end up with the identity over here, yes, it's Gaussian elimination, but this is what is referred to as reduced row echelon form. That's the idea that it forms a staircase, okay? And so by definition, it is in a row echelon form. So row echelon is the idea that these aren't just ones, okay? They aren't just ones. Reduced row, there's ones there, okay? The leading entry is a 1, cool, and in each column containing a leading 1 as zeros everywhere else, true. And the idea is that it's a staircase design all the way down the line, okay? Now, it's quite possible that we could end up with a situation like this at some point. This would be an issue. Think what this says to me. This would say to me is we would have, in this case, you may remember this back in the day, what would happen if you had the same line in Algebra 1? If you had the same line, how many points would they have in common? They'd have infinitely many points in common. And you'd end up with what would refer to as a dependent set. So you'd only have 2 variables. One of your variables you see went away here, right? We have an x and a z. We don't have any y's. Okay. So it could be a situation like this. This would actually be that situation. The whole bottom row went away. If there's a c here, it'd be the case of what you'd learned back in the day in again Algebra 1 or somewhere where you learned you'd have parallel lines where there'd be no solution. Okay. So we're going to talk more about this as we go. But you think back about that back to Algebra 1, there's only three things that can happen. You could have two lines that intersect at a point, which of course you can take that and extrapolate it out. Whether it's in 3 dimensions with a plane or whatever it happens to be, there's one point where there's one solution. There could be parallel lines, which means that there's no solutions. They never cross one another. Or they could be, if you will, the same line. Oops, that's the same line. And because of the same line, they have infinitely many points in common, yes? Infinitely points in common. So the idea would be there's infinite number of solutions there. Okay? And so, kind of keep that in mind as we're going along. We're going to solve a bunch of these guys using this reduced row method. Okay? I will show you there is a way to sort of simplify it later on. And you can kind of see what I mean by that when we get to one. Again, not too terribly difficult. Not the easiest thing either on the planet. So let's do... Oh, I don't want to do that one. No, that's gross. Okay, yeah, let's do this one here. So if you had this... I want you to solve this equation. You're like, well, now, whoa, Jay. To have 3 equations, you need 3 variables, you need 3 equations. You're right. This thing has no solution. Are you with me? So, I mean, it's not when I say no solutions. It has a bunch of solutions in effect. Okay? So, let's see what happens here. For instance, let's try this baby on for size. Let's just see what happens here. Now, we know this thing does not have a way for us to solve this. We know we're going to end up with a problem here in a minute. Okay? But let's see what problem we end up with. Now, can I get a 0 here? Well, yeah, you can. But what will that prove to me? I don't know. Let's find out. Let's just go with it. See what happens here. Okay, so if I were to do that, obviously I would take, I don't know, 2 row 1 plus 3R3, or no, R2. Try again, minus 3R. And let's see what would happen. So if we don't touch the top one, the bottom one's going to become a 0, obviously. 4 plus 3 is 7. And then you're going to end up with 2 plus 9 is 11. And then you're going to end up with 6 plus 12 is 18, I think. Nice. Now you're like, well, where do I go next? Well, that's a good question. So we could do this a couple different ways. But let's just see what happens, for instance, here. Let's say that I want to create a 0 here. Could I do that? Well, we sure could. So we could take 7R1 minus minus 2R2. Let's see what would happen. Now, where are we going to write the answer? We're going to write the answer on the top row. So bottom row we're not fooling with this time. And let's see what we get. We're going to get, obviously, 21 plus 0 is 21. And that's going to be 14 minus 14 is 0. That's cool. And then you're going to end up with 7 minus 22 is negative 15. And then you're going to end up with 21 minus 36 is negative 15. Oh, that's great. That's awesome. That's great, Jay. Okay, cool. So I'd like to get a 0 somewhere. Okay. Could I get a 0 here? Well, I sure could. But if you get a 0 there, here's my question. If you had a 0 here, can you end up with a 0 here? No. In other words, there's no way we're going to be able to get rid of everything. Okay? So could you solve for the top one? You sure could, and I'm going to. Okay? And the top row then would just say, hey, x is equal to something. But then you'd end up with an equation on the bottom that would have to be true. So let's see what happens here. Okay? So in this situation here, and this is just gross. I don't want to do this, but I have to because I'm the teacher. Oh, wait. It's not so bad. Let's divide by Let's divide by 3, top and bottom, shall we? Yeah, that's hot. So it's going to be 7, 0, negative 5, negative 5. That's nicer. It's not pretty, but it's nicer. All right, now let's take 11 R1s. Yes, minus 5 R2s. And let's just see what happens, shall we? So you're going to get, we're going to get 77. And then you get 0 minus 35. Oh, geez, now I'm back to here. And then you're going to end up with 0. That was the whole point. And then you're going to end up with negative 55 minus 100, minus 90. Ugh. No, yeah, negative 55 minus 90 is... That's disgusting. And then, of course, the bottom didn't change. And you're like, well, why did I waste my time doing that? That's a good question. I don't know why you wasted your time doing that. What you're saying is this. We knew going into this problem we couldn't solve it. Are you with me? There's no solution for this guy. I did my best. I got it into a reduced, not reduced. I got it into a row echelon form. That is, it is a stair step down where this one starts with a number and then it goes down. This one starts with a 0 and then it goes down. It is in a row echelon format, but I cannot get to reduced row echelon format, and I cannot solve this. And I cannot solve it in this case because I have more variables than I have equations for. Okay? But what is this telling me? It says, listen, if you take 7x minus 5, z, as long as it equals negative 5, and 7y plus 11z is equal to 18. As long as you can pull this off, you can solve this equation. Like, well, what do you mean, Jay? Well, let's find out. So let's pick an x. I pick x to be 0. Cool. Well, if x is 0, that forces z to equal 1. Is that true? Well, if x is 1, or z is 1, that's 11 here, yes? 18 minus 11 is 7. That forces y to equal 1. But Jay, why'd you pick 0? Because I felt like it. Could you pick something else? Of course. What do you want to pick? 10? Sure. So if x is 10, that's 70 minus 5z equals negative 5. I suck at math, so let's do some manipulations here. So you get 5z is equal to 75. That means z is 15. But if z is 15, then we've got a mess on our hands. 11 times 15 is 165, I believe. And so 18 minus 165 is, I don't know, let's ask Betsy. Negative 147. Negative 21. So 10, negative 21, and 15 would also be solutions. The idea is that there's an infinite number of solutions because this equation, or this particular set of equations, we have underdefined the system. We have not given ourselves enough equations for as many variables as we have. Okay? With 3 variables, I need 3 equations. Just how life goes. Suppose I told you this. I kind of got a thing for 3x today, I think. Sorry. Wait, what? You've got 4 equations with 3 unknowns, Jay. Yeah? What's the point? Well, Jay, I feel like they all have to be true, right? Right? Well, then all I need is 3 of these equations, right? I know, but I gave you 4 of them. Well, why would you do that? Just go with me. Just go with me, friend. Let's just see what happens. Now, the thing I love about linear algebra is, if it's done correctly, like I try to do it anyway, you keep in mind that a real-world solution must exist. And that's what's interesting about this. Not the, well, if you have this random, no, I'm not really into that. Now, this is beautiful because in order to get zeros here and here, it's pretty straightforward, I think. I'm going to do, what do I want to do here? I want to do 2R1. Actually, I'm not going to do that at all. I'm not going to do that at all. I'm not going to touch R1. Not going to touch R1. So what I'm going to do, ouch, well, yes, I'm going to touch R1, but not for a second. So I'm going to do R2 minus 2R3. That's the first thing I'm going to do. So 2 minus 2 is 0. 2 plus 2 is 4. 2 plus 2 is also 4. 8 minus 0 is 0. And then for this guy, I guess I will take R1 minus 3R3. So it's going to be 3 minus 3 is 0. 1 plus 3 is 4. Is that right? Is that right? Yes. Right. And then it's going to be 4 plus 3 is 7. And then it's going to be 8 and 0 is 0. I'm sorry, 8 and 0 is 8, you idiot. Is that right? I did that wrong on this one too, didn't I? R2 minus 2. Yeah, these both should be 8s. Correct. And then I didn't touch the bottom one. Nice. And you're like, well, let's get zeros, man. Okay, I feel like, all right, that's cool. Sounds good to me. So where do you want a 0? Well, I need zeros here and here for starters. All right, cool. Let's do that. So if I were to do that, and here too, right? Cool. Matter of fact, right after that, I'm going to take R1 plus R4, or not plus 4, minus R4. So that's going to give me 3 minus 0 is 3. 1 minus 1 is 0. 4 minus 6 is negative 2. 8 minus 7 is 1. Again, I want that one to stay put, so I'm not going to fool with this row. But this guy I'd like to go away, so I'm going to take R2 minus R3. So that's going to be 0. Minus 0 is 0, obviously. 4 minus 4 is 0. 4 minus 7 is negative 3. 8 minus 8 is a goose egg. That's hot. And then I'm going to take something like, I feel like R2 minus 4R4. And it's going to give me 0, 0, 0. And 4 minus 24 is negative 20. And then it's going to be 8 minus 28 is negative 20. Well, that's nice. And so this bottom row, you're like, well, let's divide by negative 20. Oh, I like that. That's cool. So you're going to get nice. Now, interestingly enough, you're like, well, wait, couldn't I just divide this guy by negative 3 as well? Well, yeah, well, yes. 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 And so I can do that. I should have done it at the same time. So that's going to be okay. Now, let's continue on just our merry way here just for a good time. Let's do R1 plus 2R3s just for fun. And so, just want to show you what happens here in a jiffy. So it's going to be negative 2 plus 2 is 0, yeah. And then it's going to be 1 plus 0 is 0, so that's handy. And then I also want this guy to go away, so I'm going to do R2 minus 4R3s. It's going to go 0, 4 didn't change, and then 4 minus 4 is 0. And then it's going to be 8 minus 0 is 8. 0, 0, 1, 0, 0, 0, 1, 1. And you're like, well, are we done? Not quite. Because for this to be in reduced row format, well, what I gotta do, I gotta divide by 3, so that's cool. So that's easy enough. I'll make this equal to a 1 then. And then on the second row, I'm going to divide by 4, so that puts us here and here. That's nice. But this isn't in reduced row echelon form. It needs to be a stair-step fashion. So I'm hypothetically, what if I took R3 minus R4? What would happen? If you took R3 minus R4, you would end up with 1, 0, 0, 0, 0, 1, 0, 2, 0, 0, 1, 0. And then you'd end up with, well, hang on. Back the train up just a hair. Right, so, and then, well, I want our answer to go here. So let's do this. So, so you say, right, R3 minus R4. So 1 minus 1 is 0. And then 0 minus 1 is negative 1. And then you're like, well, this row down the bottom is this. That's true. And then, again, still not a reduced row echelon form. Because to be there, you would have to be like this. Oops. And now it's in that stair-step fashion down the line on this side. Notice it stair steps down. Okay. This bottom row is weird. It's odd. It's very strange. And you're like, I don't really get why x plus y, 0x plus 0y plus 0z equals negative 1. That's kind of strange. And in fact, I think I made a little bit of a boo-boo. And so we'll see what the final answer was. The final answer was 0, 2, 1, which I think is supposed to be the correct answer. 0, 2, 1. No, I made a boober somewhere, I think, friends. I think I made a mistake. I'm going to pause you for one moment. Okay, I see my mistake. When I was making this problem up ahead of time, I made a boo-boo. So the answer was supposed to be 1, 1, 1. But here you see 2 plus 2 plus 2 is not 8, you idiot. It's 6. Okay, so I'm going to tweak this ever so slightly. See if I can save this for you. See if I can save it for us. No, I don't think I can. I'm just going to start over on another page. I'll do it on the other page separately. You just, I don't know, change what's different, I guess, a little bit, huh? It kind of messed things up, the fact that I had that wrong. So if I had done it correctly, then everything would have worked out at the end and I'd have been really like a superstar or something. So I'm going to do R1 minus 2R2. No. R1 minus 3R3. That's the first thing I'm going to do. And that's going to give me oh, stop it. Leave me alone. I'm going to do R2 minus 2R3. That's the first thing I did last time. I'm going to do it again this time and see if I can not screw it up this time. Good night. So that's 2 minus 2 is 0. So that's nice. I'm going to change. I'm not changing the second row yet. I'm changing the third row. And then I'm going to take, no, I'm actually changing the second row. So 0, and then I'm going to take 2 minus a minus 2 is 4. And then 2 minus a minus 2 is 4. And then 6 minus 0 is 6. That's okay, so that's different. Okay. And then I'm going to take, this is the exact same thing I did last time, R1 minus 3R3. And I'm going to change R3. So that's going to be 3 minus 3 is 0. And it's going to be 1 minus a minus 3 is 4. And then it's going to be 4 minus a minus 3 is 7. I don't think that changed. And then it's going to be 8. There you go. Okay, so I think there's not that ton that changes, but if you don't fix it right now, you're going to be upset with yourself, I think. So I want to have this guy stay put. I want this to be a 0, so I'm going to take R1 minus R4, because that's just an easy gimme right now. So 3, 1 minus 1 is 0, 4 minus 6 is -2, 8 minus 7 is 1. Not changing the middle row, because again, I need that guy to stay put to get the right format. I need this guy to go away, so I'm going to do R2 minus R3. So that would be 0 minus 0 is 0, 4 minus 4 is 0, 4 minus 7 is -3, 6 minus 8 is -2. And then this feels goofy. And then I'm going to take R2 minus 4 R4s and see what happens there. So that's going to be 0 minus 0 is 0, 4 minus 4 is 0, 4 minus 24 is -20, and 6 minus 28 is negative. I guess this is what you get for, I don't know, not paying attention to yourself. This shouldn't have been a 0. That should have been a -1. Oh, I'm dying. I'm dying, friends. All right, R1 minus 3 R3. R1 minus, so that's 8 minus the -3 should be 11 here, looks like. R2 minus R3, so 4 minus 4 is 0, 4 minus 7 is -3, 6 minus 11 is -5. Amazing. I actually can do arithmetic now. Judas frickin' Priest. All right, here we go back. Same one I did previously. There you go. I got to here, yes? It didn't change, I don't think, on that one. But this is where I messed up, was on the second one. So R1 minus R4. And as you can see, I get a 0, 3, 0, -2, 1 across the top when I did that. I'm going to take row 2 minus 4 R4s. So this guy minus this guy. And write the answer down here in the bottom. And so this, I was messing those two up last time. Also, I did R3 minus 4R4. So this minus 4 times this, and I got here. And again, I messed those up before as well. What you can see is these bottom two are identical now. And so one of them is clearly superfluous. I don't need it. That make sense? See if I can do this properly without screwing everything up. So what you've done is you've over documented the problem here. You've given me more information than I needed. I can still solve it, but I don't need that because this bottom row is redundant. And so we have 3, 0, -2, 1, and 0, 4, 4, and 8. At this juncture, someone might very well say you could divide that second row by 4. You could, but I'm not opposed to some larger numbers. So let's just go ahead. We need to get a 0 here. To do that, we're going to take what? We're going to take and here as well, right? So what we're going to do is we're going to take R1 plus 2R3. And we're going to write it up there. And we're going to, so it's 3, 0. And then -2 plus 2 is 0. And then 1 plus 2 is 3. And then to get and then to get a 0 here, I'm going to take R2 minus 4R3. That's going to give me 0, 4. It's going to be 4 minus 4 is 0. And then it's going to give me 8 minus 4 is 4. 0, 0, 1, 1, 0, 0, 1, 1. Again, these two here are redundant. So when you do this, if you divide the top by 3 and the middle one by 4, you get 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Turns out that the answer is 1, 1, 1. You just gave me extra information that I didn't really need. Okay? Piece of cake. Now, those are the gist of how these guys work. It's, again, almost fun. Not terribly fun, but almost fun. You can solve a couple of other ones like this. We're going to bust through a couple of them here. So, for instance, what would happen if you saw this guy? Oops, there's no commas in matrices. There's no crying in baseball. Will this have a solution? No, it won't have a solution. Why? Because it's underdone. Would there be a unique solution? No, there's no unique solution for this. There's infinitely many solutions because you do not have enough equations for as many variables as you have. You have 4 variables. You have 2 equations. Okay. In a situation of whether it's a situation like this guy here, for instance. Okay. Would this guy have one solution, infinitely many solutions, or no solution? Well, this is infinite, by the way, right? We know this. This looks like 3 equations with 3 unknowns. Okay. To do this out, you have to ask yourself, can I write R1, for instance, as some multiple of R2 plus some multiple of R3? If you can, then we would say that there's no solution. Okay, well, that would technically be infinitely many solutions. So if I could write one as a linear combination of the 2, then I would have a redundant setup there, and I'd only have 2 equations. Okay. Then another question one might ask oneself is, can I solve this guy? If I did, what would no solution look like? Okay. Well, if I had this. Equals A, this is a 1 solution setup. This is what 1 solution looks like. That's cool. What would no solution look like? So what I'm going to do is I'm going to take 2 lines that I know are parallel, planes I know that are parallel. And you're going to say, Jay, why are you solving this equation? Because you know they don't cross. Well, just go with me here. And 2, I'm going to do 4x plus y plus z equals 12, and then 3x minus y plus 6z equals 10. Now, I did this because obviously the top 2 are parallel lines. They have the same exact slope, different, if you will, constant over here. They cannot be the same. They both can equal 9 and 12 at the same time. That won't be as obvious sometimes in the data. So, but if it were this obvious, that'd be nice. It just doesn't always work out that way. As a matter of fact, it never does. But let's see what you get when you run into one of these guys in the dark alley. Let's see what happens. Okay. Well, look, I need a 0 here. Well, that's easy. So I got to do R1 minus R2. Cool. Sweet. And I am going to end up with 4, 1, 1, 9, 0, 0, 0, 3, negative. And then this. Here's a problem, friends. This is saying that 0x plus 0y plus 0z is equal to negative 3. Or in other words, 0 equals negative 3. You can't do that. There is no solution. Now, I do remember this one time years ago. I think the gal's probably in her 30s now. Probably has a couple of kids. I don't know. But she one time literally asked me, Mr. Groom, why can't 0 equal, and it was 0 equals 2. Why can't 0 equals 2? And I'm like, and she's dead serious. I'm like, I said, well, they never taught us why that was in college. It was just obvious, I guess, because this is 0 and this is 2, and then no. So in this situation, is no solution, right? And why was it no solution? Because these two planes were parallel to one another. Okay, it won't always be that obvious. Okay, it won't always be that obvious. So just be aware of that going forward. Okay, likewise, it won't always be something as easy as this, where geez, these are the same equation. It won't be like that. So just be aware of that. And again, what would happen if they were the same line? What would happen if they were the same line, the same equation? This would be a 0. Can x plus 0 plus 0 plus 0 equal 0? Sure can. What does that mean? It means infinitely many solutions. Okay, that's how you'll be able to tell them apart. Okay, so just be aware of that going forward. They're not terrible, but yeah, there you go. Now, we're going to spend just a couple seconds here going over the ideas of what I want to talk about is the difference between well, actually, one more thing I want to say. Is there any reason why I couldn't have flipped these two rows around? No, in fact, you can always flip rows around as well. That's something else that you can do. So in addition to multiplying or dividing by a constant and then adding a couple rows together or subtracting them, you're also welcome to flip rows around as well. Okay. Just wanted to go back here and touch on row echelon format. And I want to run through the exact textbook definition for you. Oh, where did it go? Oh, brother. Yes, row echelon form. So a matrix is in row echelon form. If any rows consisting entirely of zeros are at the bottom, and in each non-zero row the first non-zero entry called the leading entry is in a column to the left of the leading entries below it. In other words, a stair step. This is reduced. This is row echelon format. Okay, this is row echelon. Notice that it does not have to have the zeros here. You with me? It does not have to have that. Okay. Now, we don't do a ton of just echelon form. Okay, we typically continue all the way down to reduced row echelon format. And so reduced row echelon will always look like this. So reduced row echelon form satisfies the following properties. It's in echelon form. So stair stepping, right? And the zeros are at the bottom if there's a full zero row. Okay. The leading entry is a 1. And each column containing a 1 has zeros everywhere else. Okay, and so we've messed around with that a little bit. That's kind of a big deal. Okay. So another term we're gonna mention here briefly, and it's a big deal, we'll spend a ton of time on rank later on, is the number of non-zero rows when you are in row echelon form or reduced in row echelon form. Okay, this is a huge, major deal. Okay, 3 equations needs three unknowns. Needs 3 equations, right? We know that. Okay, to solve that equation, you must end up with a rank of 3. Okay, in other words, there better be 3 rows that are non-zero. Okay, now we did several of those back here. For instance, that guy right there had a rank of 3 because there were no non-zero rows. Are you with me? And there were 3 non-zero rows, I should say. 3 non-zero rows. This one here also had a rank of 3. This one here had a rank of 3 when I did it right. When I did it right, it had a rank of 3. Where did I put it? No. For God's sakes, is this the one I did right finally? No. Where's the one I did right? Didn't I do this one right? No. I thought I did that one right somewhere. This one here, no, we didn't finish that one off. What? I thought I did that one right somewhere finally, didn't I? Aha! 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 So if I were to take and do this guy right here, if I were to take and do R3 minus R4, what would I end up with? 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0. This would still have a rank of 3. Why would it have a rank of 3? Because there are 3 non-zero rows. Okay? So that's a big deal. Rank, we'll do a ton more with rank later on. Rank is what it's all about. Okay? When it comes to statistics later on, if you look in statistics and you talk about how many variables, your design matrix needs to have full rank, otherwise you're not going to be able to find any data out of it. In other words, there won't be a solution out of the thing. So it's kind of a big deal. There's so many other reasons for that as well. So we'll get into that more when we get on doing it, just so that you're comfortable with it. So you're going to be identifying some of those. You're going to be doing some solving. I do want to show you this in your calculator. Now, we will be doing this later on. I'll allow you to use your calculator on some of it, but some of it you're going to have to do by hand, and you'll have to show me that work by hand. Now, to create a matrix, okay, you can do the following. Okay, I'm just going to show you a quick matrix here, and then I'll show you what I'm going to do next. So, semicolon. That gives you a 2 by 2 matrix. The semicolon denotes the rows. Okay, let me pause for 1 second here. So what I can do is I can actually create an augmented matrix the same way. So what we'll do is come back to the one that we did earlier. This one. No, not that one. That won't work. Let's do one that we know works. This guy here, yes. So we're going to type that guy in. So to do this in your TI-89 calculator, it's going to be 3, 1, 1, 11, semicolon, 1, negative 1, 2, 4, semicolon. Oops, that is not a semicolon. Semicolon. 2, 2, 1, 9, bracket. Okay, and then I like to store them, so hit stow as a matrix, so matrix A. There it is. Now what you guy can do is go to math, so second number 5, matrix, which is number 4. And if you scroll down a ways, you will find reduce row echelon form. Done. And like Jay, I saw an REF, row echelon form. You did. So that's row echelon form. So it puts it in row echelon form, but not reduced row echelon form. Again, no one's ever going to ask you to do that except in a textbook, and I certainly am not going to ask for that. Reduced row, big deal. Row, no. That's nice. It's wonderful. It's great. It's whatever. Okay. We are going to talk more about a different way of solving as well in section 2.3 a little bit. We're going to talk a little bit about that. Actually, this video is a little long, but it's not too bad. I'm going to do one more thing here before we get carried away. We'll see this again later on as well. You may have seen this, you may have not. When I first saw this back in the day, I about died. I thought it was the coolest thing I've ever seen in my life. Teacher showed me this, and when I saw what she did, I was just like, no way. So I take a 2 by 2 matrix of the coefficients times a 2 by 1 matrix. So a 2 by 2 times a 2 by 1. What do you get? Well, you get a 2 by 1. Well, if I was to solve for this guy right here, I'd need to get rid of this guy. So what I need to do is I need to multiply by, and let's just call him A. So if I have A times X equals Y, what I need to do is multiply by A inverse. Now remember, multiplication of matrices is not commutative. So if I do on the left over here, I need to do it on the left over here as well. This will give me the identity matrix times X, which is in essence just X. And I have A inverse times Y. And so to do that on my calculator, I think that's kind of an interesting deal. So I'm going to go, stop it. So 2, 1, semicolon. Oh, what in the heaven's name is going on here? Stop it. Stop it. And I'm going to stow that as, I don't know, B, I guess, because I can. And then I'm going to do bracket 9, semicolon, 11, stow, no, don't do that. Don't do that, I said. Stow as C, I guess. Cool. So I'm just going to take B. We'll take the inverse of B. So B to the negative 1 times C. And I get 4, 1, which is the correct answer. And so this is what's referred to as the matrix equation. We will do more with him later on. What I want you to feel comfortable with is when we're all said and done, this reduced row echelon form, which is a very important thing. We're going to use it a ton. So that's why I make a big deal of it. I've never been a big fan of reduced row echelon format. It's okay. Nothing wrong with it per se. It's a lot of work sometimes. But the reason I like it is we'll end up using the same techniques, that is Gaussian elimination, to take and reduce a system down to see, for instance, does this matrix, for instance, have full rank? We'll ask later on. I don't know. We'll find out. We'll use it later on, do the same kind of things to find basis matrices and other things like this. So the same technique will be used over and over and over again. That's why I really beat it to death. If it weren't for that, I'm not sure that I would teach it anymore, to be quite honest with you. Okay? But the techniques that we use, that technique will be used again and again and again. And for that reason, I find it very important to continue teaching it. Okay? So that's section 2.1 and 2.2, primarily 2.2. Primarily. 2.1 is just kind of an introductory thing. So this is basically 2.2 in a nutshell. It's not very hard to do. And I think you'll have a good time with it. Don't panic when you make a boo-boo on your multiplications. If it were me, I would go back and double check myself using this. If you need this calculator, I'm going to put that up on our website for you. I think it's already there, but if it's not, I'm going to put it up there. Feel free to download the emulator and use it. Okay, yes, you can use it on the test. However, when I say show your work, you need to show me this whole thing on the test. If you don't show me the work, you're not getting any credit for it. Of course, you're always welcome to check yourself. Okay, I knew when I got done earlier, I made a boo-boo on this one because it didn't work. All right, when I plugged it back in, it should have worked. It didn't work. Okay, I got a problem. I didn't need a calculator to tell me that. I could see it didn't work. Okay, but it's nice to be able to check myself. Okay, this is what the answer is supposed to be and work towards it. But I will be double checking you as we go along. I like about this much of showing work where I say 2R1 minus 3R3, that sort of thing. I like that. I'll figure it out from there. If I was asking you to explain it to my boss at the high school, you'd have to be a lot more descriptive than that. But for me, I get what you're doing and I'm good with it. All right, 1 hour, 1 minute. That's pretty good. I'm done.